Here, if you look at the graph shows you that there's a special voltage called the stop potential that no electrons will flow. As we increase the voltage, the current will continue to increase, right? And the current stays the same at a particular, right? And doesn't change as the voltage changes after a while, right? In order for us to increase the current value, all we have to do is increase the intensity of the light coming in, right? The more radiation coming in, the more electrons will leave. Okay? So intense means more radiation coming in. That's all. All right? The more intense, the more electrons will leave. All right? And the bigger the current reading. This value here is the stopping potential, right? Right? These were the problems here. These were the 4 problems that classical physics could not explain. And then modern physics explained it by simply looking at every single photon as having as light being a photon, which is a particle property. Okay? And the energy of every photon is equal to HF. And then we said that this formula here summarizes every single thing. Right? The energy supplied by the radiation goes towards breaking the bonds. What do we call that again? What is called HF naught? We get it with W. Work function, right? So the energy supplied goes towards breaking the bonds, and the remaining is the kinetic energy. Everybody okay with that? That's the formula that summarizes everything. So if I ask you to summarize photoelectric effect, I expect you to be able to say something like this. All right? And I think I gave you some formulas. HF is equal to HF naught plus kinetic energy. I also give you HC on lambda is equal to HC on lambda naught by EVS. Anybody remember what F naught? F naught is your threshold frequency, minimum frequency required. Right? That's the minimum frequency required for the whole thing to happen. What was lambda naught? Threshold wavelength, which is the maximum wavelength it will happen at, right? And then, well, we'll look at the graphs today, right? We'll do some calculations first. What I did for you here, I did a summary of everything here. What's the photoelectric effect? What's the work function? What's the threshold frequency? What's the cutoff wavelength? Stopping potential, and all the formulas you need. It's in the handout I gave all you. Everything here in the group. I sent the handout last week. But now still all you reading from the handout. Anyway, so all I wanted to do is have this close by. So we could begin with past papers on this now, right? Let's just read it over one more time now. For those who now reach the class because they wasn't traffic, right? Traffic. So the photoelectric effect is the ejection of electrons from a cold metal surface when EM radiation of sufficiently high frequency falls on it. That makes sense? Every word? Yeah? I tell you, everything makes sense there? You sure? So since you say it makes sense, right? What would happen if the frequency is lower than a sufficiently high value? By the way, what's the frequency they're talking about there? I'll tell you. Special frequency. What's the frequency they're talking about there? Oh, wait, I'm moving on to like America. What is that frequency? I just studied the name of it. Threshold frequency. Very good. Threshold frequency. Okay? Nice. Right? So when EM radiation hit the metal, electrons leave it. What do we call those electrons again, Jacob? Huh? The electrons are called photon. We're close with photoelectrons. Same thing, eh? That's nowhere close to being the same thing, eh? The photoelectrons is what leave, and the photons is what hit them. So let's think of maybe a bad example, but think of Venezuela, right? When anyway, we're not going to that. That's a bad example. Right? The function of a metal is the minimum energy needed for a free electron in the metal test heat. Are you okay with that? You okay with the definition? Shazana gonna ask to explain it. Huh? Work function is the minimum energy needed for the electron to leave. Are you okay with that? Threshold frequency, until you just explained that to us. Threshold frequency is the minimum frequency for the radiation to cause the emission. You okay with that? Cutoff wavelength is the reverse, right? Cutoff wavelength is the maximum wavelength that is capable of rejecting electrons. The wavelength, maximum, frequency, minimum. All right, please remember that. Huh? Next, stopping potential is the amount of potential that is required to stop the electron from having maximum kinetic energy and moving. Okay? Right? And stopping potential. What's the photon current Chinese? And stop calling it up because I'll be laughing. Cristiano. Same Chinese. Cristiano at when we stop in potential, at stopping potential, what is the photon current band? Exactly. What else? How about nap story Monday? How about nap story Monday? Say it. How about nap story Monday? Zero. The answer is 0, right? So the current reading is 0. As a benefit, man, first. Napsan press type per second. Right. Nice. And these are the formulas here. I gave you them last week, right? If it's the first time you see it in your life, write them down, please. Although it's in the summary, write them down. I gave you all of this last week. What H again? H is what? H is Planck constant and the value is what? 6.63 by 10 to the minus 34. Copy it down and let's go to some past papers, right? Any questions online? I told you all to work in graph paper. Because where I do the graphical ones there. Where I do one graph. 1, 2, 3, 4, 5, 6, 7, 8, 9. No, I said 8 and 9. 8 and 9. Who have graph paper? Sana, you saved the class there. Well done. Lava will love, okay, all right, let's go. Pardon me, sir. But yeah, time to go for a mark and then come here later. All right. It's in the handout. Check the handout. Oh wait, let's ask somebody sun plugging. Anybody missing this? Oh, we're missing. You'll come to up. Yeah, it's not super short. Somebody from Wednesday class.
I missed another.
I was the 16. I was 60.
Nah, it's not. Huh? Yeah. Is that yours? Oh, but it was summer right there, finance. Well, on Wednesday. Right, if you'll check on the, if you're on the handout today, I want to write it down. Hurry up, write it down fast and let's start. Oh wait, that's Sylvester. And let's go to a question, right? Right, these questions come a lot on the graph. On the graph as well, right? So, sorry? I am. Today is still normal, half six. Are the next time today?
No.
Alright, let's go. Colin, do you wanna give your last week? We'll go. You wanna give your last week? What was sodium and the work function? Yeah? Alright, nice. Right, right here down now. That was 2003. Paper 2, number 8. Right? That was the one from last day, right? No, that's from last day. I don't hold on, I have to get back a photo because the one I have here is not good at all. Next one is 2005, paper 2. I'm gonna show you that. I'm putting it in 2 parts, right? Because Cristiano, I put Cristiano. Put slash China. But they have it. So the first part is just pure definition, right? Are you okay with this? Work function, threshold, stopping, and what's part two though? What property of light does the photoelectric effect display? Cristiano. What property of light? What are the two options? Particle. Right? Particle is the answer. 1 mark for that. Right. Take a look at the graph. But let's zoom out a little bit for you, right? Right, that's the best I can do that. So in the photoelectric effect, the intensity of blue light on a metal, and they gave you the graph. Does that graph look familiar? Looks familiar, right? That's the graph of current versus voltage. First part, what conclusions can be drawn from the plot? See if you can write the conclusions. You should be able to have at least three conclusions. Have three main things happening there. Something happening here with the eyes, something happening here with the VS, and something happening here with the straight line. Something that we started last week, photoelectric effect. Photoelectric effect.
Oh, like sign on thing.
Yeah, same thing we did last week.
But is it red? Is it red? Oh, wait. We can get what you want. Yeah. I don't know if you saw it, so the way that the down, but still. I was thinking about what is like, seeing a little bit like, I'll find somebody. Also, if you want to, you don't see, if it's possible, you think I can. You get little bit. Like, see, like, no, can't think that's all. Yeah, I don't know. Oh. How was I like that? Oh, you just got to. Was that? One that thing from the person.
Yeah. First conclusion is what?
potential will be
Stopping
intense, right?
right. See, stopping potential is a constant value regardless of the intensity. And what else happens at stopping potential? Current reading is zero, right? Photo current reading is zero. Thirdly, what's a third conclusion? Right. As I increases, the photo current increases. Anything else? What does this straight horizontal line here say? Go ahead. So once the voltage crosses zero, current is independent of the potential. Very good. Someone else smarter, but okay, smart better. Try part 2 now. Explain how the maximum kinetic energy and maximum velocity of the photoelectrons can be deduced from that plot. Take your time, right? Real easy, don't overthink. And then we do the calculation. Right? We all come up with. How we getting the kinetic energy? But we can't get that from the graph. From the graph. Any ideas online? What you all think? Look at what the graph given here and look at the list of formulas I gave you. Right? And how that helping you? Right. No, not number electrons, chargeable electron. Right? So kinetic energy is equal to EVS. Right? And if you know VS, I know the charge by electron, then you can find the kinetic energy. And if you know the kinetic energy, you can find the speed. Are you okay with that? Are you okay with that? Yep. Online, are you okay with that, Katrina? So from the graph, all we need is VS. Are you okay with that?
So you can explain you're gonna get EBS like most of the potential.
Right. Well, I don't know if you remember. I was telling you that last week I was showing you how they can go from joules to EV. Right. But remember, both down is what? Charge by voltage, Q by V. So if you have the charge by electron and you have VS in voltage, if you have the charge by electron and you have the voltage required to stop the electron, then you can find the energy that the electron has. As you remember, the VS is to stop the electron going with the highest kinetic energy, right? That's okay. So you remember WQ by Go ahead, check part C. Check part C. Again, write down everything. Right? You have watts per meter squared, you have wavelength and so on, right? Take your time, already wording tricky, yeah? But simple. My water, okay. Take your time, write down everything they give you, pay attention to the units and everything.
lambda is equal to h on e where p is a type of p. That's why I add to the line. That's the fifth question.
Right, can you go?
Hey, I guess we have a couple of
What?
Hey, didn't actually talk to you.
The security. I think what the office. How many the office? Alright. Any more?
Try. You did
Try it.
try the truly. Before. And that takes us like a piece of base. That's equation.
Lambda is equal to.
H on p where p is equal to. Oh, I don't know.
So I didn't give no you, P is momentum. I give it I. We don't need I here. So light intensity, you all recognize what that is? That's watts per area, right?
Yeah.
You see that? Nice. They give you a wavelength of the incident light, and they give you the area incident on. It reflects 95%, so only 5 will remain, right?
Yeah.
The threshold, they give you F naught. Okay? So you should have all those things listed out. You have that clear? Right, good. Find the intensity of light available. Real simple. So the intensity of light available will be the intensity by 5%. Very good. That's all. I told you ask for the intensity available. How much is that? 7.5 by 10 to the minus 4.
Yeah, some of them.
And up in the office. No, it has so. Anyway,
I don't know things to know things to do.
that's about what running people out there. 10.5 by what? Minus 4. Huh? What's per meter squared? Nice. The number of electrons per second. Number of electrons per second. What is that? Think about it, huh? Think about it. Number of electrons per second. What are they asking for? H by C. H by C now. Think about what you have here. So I just asking one question again. Huh?
Yeah.
Which E? Right, remember that he has energy and he has charge by electron, right? H by well again there. Alright, so let's go simple. So we have light hitting the metal, right? We have light hitting the metal, and we know that every photon hitting the metal will give you 1 electron. That's okay? So is it possible to find the number of photons hitting the metal? Right? So it's a little bit hard, so I want to help, right? What does force mean? What is power, right? And power is what? Energy divided by time. Very good. Energy divided by time. So technically, what we have here is the Very good. It's joules per second. It's energy hidden per second. That's okay? But do we know the energy of one photon?
Yes.
That's what? That's what? No, Planck constant is just each other.
Charge and by the loss.
Huh?
Yeah, did not charge by yes.
No, Chinese was saying that a while ago.
Yes, okay.
EHC on lambda. Right? Because if you know the wavelength of one photon of the incident,
Yeah.
right? We know the wavelength, we know the speed of light, and we know H. So that will give us the energy of one photon. Okay, Ram? I'm explaining it again, right? We have the intensity of light. That's the power. Power is energy divided by time. So technically, we have the energy hitting every second. So now we need to know in that energy how much photons in there. So in order for us to find it, we have to find the energy of one photon, HCl now. Go ahead. And then find part 3 and 4 are almost straightforward. Work it out, then I'll go and do the whole thing. So I have question from
Now,
again, two, diffuse it. Finish part 1 6.
6.6 right at the four.
So you can do part 3 and 4 too.
Cool.
yeah.
When I finish two, do 3 and 4 now, please.
But I haven't been to the part of the
I'm trying to. So, yeah.
Try 3 and 4. I want to go on board, right? Dash it down. Okay, 3 and 4 simple, right? They will function and they give it threshold. And stop the potential and you have everything already. Okay. Not too much to do. For the guy graph page, right? Online you need graph people for the next one. Taking it off, right? Right, Sylvester, help me out here. Some more about this again, right? So part one was what again? I was how much? 7.5 by. Right, so part two now, we said that I was really 7.5 by 10 to the minus 4 joules per second. So now we have to find the energy of one photon, that's 8 C on lambda. So that's 6.63 by 10 to the minus 34 by 3 by 10 to the 8 all over 250 by 10 to the minus 9. So that energy value is 7.9 minus 19 joules. So we know EP, right? So therefore the number was falling apart there, boy. So therefore the number of electrons is equal to this, this divided by this. 7.5 by 10 to the minus 4 over this. 7.956 by 10 to the minus 90. How much is that? How much is that? All into it?
Yeah.
Yeah, you all do it, but I no answer. How much? 9.43. Right? 10 to the power 10 electrons, right? Nice. Part 3. How we finding the work function? Work function is H F naught, right? So that's 6.63 by 10 to the minus 34 by
1.1 by 10 to the
1.1 by 10 to the 15. How much is that?
7.293
7.293
by 10 to the minus 8.
Right. You'll always recognize the values are around minus 19 range, right? And then part 4.
It's supposed to be very
Huh?
level.
No, it's in joules. No, it's still in joules. Oh. So we had to convert to electron volts, right? So what to do?
Divided by 1.6.
Divide by 1.6 by 10 to the. How much is that?
4.5.
4.55. How we getting PS? How we getting PS? Because I know what the power we using here. Right, I'll give you a minute to do like an origin. Take a minute.
So the
That's not shh. Or what she's on to do. By yourself. Very good. That's something good. So you take your energy of the photon minus the work function and then divide by E. I just rearrange it one time. Okay? So that value was 7.9. By the way, by watching it, will the photoelectric effect happen? By just watching these two values, will it happen?
Yeah.
Because this is bigger than this. How much is that? Wait, I get 1.6. It's was 1.6. What is charge by electron again?
Same nonsense. Yeah, 1.602. Yeah.
Sorry, I watched the wrong thing. I read the wrong thing here. I wrote the wrong thing. What's with this value? How much is this? How much? 0.41 what? Volts. Very good. Online, any questions? Are you okay online? Katrina, Judah? Are you okay with that? Ready? Next one. 2007. I give it this one because it is. Stand up, please, everybody. Come now, let's do this quick now. We have a graph here, 2007. Number 9. Oh yeah. I have one question about it now. I'll get on medal, right?
I'm trying to also.
That should be good. You the winner? Rest up, please. Take a rest up. One medal. Still here, look. I have to do it for you. Sylvester, everything now, boy.
Wow.
Finished? I have now, we have a graph to do, right? Okay, so what time? One total.
So what is?
Oh, yeah. Yes.
Yeah,
Right. 2 minutes again, I'll do it. Right? What does the 400 nanometer give you again? That's the wavelength of the incident light, right? They give you power again, and they give you the area incident on. They give you photo current, so that's a little bit different now. So the photo current has the electrons in it, right? Right. Right. Smart. Oh, I have nothing. I'll start with this now, right? Take it off. Yes. Take it. Question off. Well reach. Hands up, right? And then right there. Right, good. All right, let's go now. Let's see how this works. This one is fairly similar. So they want the number of photons incident on the area per second. Right? So they gave us the intensity. They gave us the intensity, right? So on the area, we can find the intensity on the area by saying 100 watts per meter squared by 5 by 10 to the minus 6. Right? That will give us the intensity. How much is that?
5.0.
5
5.
minus 4.
Yes.
Altogether? Yeah, minus 4. Okay, nice. So that's watts per meter squared. They asked for the number of photons, right?
Yeah.
So what's the next step?
Yeah.
So this is the joules per second, right? So we can find the energy of one photon, which is hc on lambda. So you're plugging in that value, what you'll get? 4.97. Right? And then you divide it. So to get the number of photons, it will be 5 by 10 to the minus 4 divided by 4.959725 by 10 to the minus 19. And we got how much? 1.01. 15. So 1.01 by 10 to the 15 photons. On part 2, find the number of photoelectrons. How we'll do the photoelectron part of it now. You see, this one different. This one they gave us the current. And current is charge current is equal to charge flowing per unit time. That's okay? So to get the number of photoelectrons, all we have to do is take the 5 by 10 to the minus 9 and divide it by the charge of 1 electron. How much is that?
3.1.
3.12 by how much? 10?
Yeah.
10. 3.12 by 10 to the power of 10. Part C is what? Explain how the maximum kinetic energy of the photoelectrons may be measured. How are we doing that?
I don't know.
How you will get the max kinetic energy?
So, one electron.
So all we need to get is stopping potential. That's all.
Yeah.
So all we need to find is the stopping potential of the circuit and then multiply it by E. That's it. Put that in words, right? Part 2. Write down an equation to show how the principle of conservation of energy applies to the process of the photoelectric effect. What will that be? And the formula is what? E is equal to, there's the energy of the photon is equal to the work function plus the kinetic energy that the electrons leave with. Right? The white in terms of energy, so you don't have to write HF on there. Okay? So the energy supplied by the photon, right, is equal to the work function plus the kinetic energy that the electrons leave with. That's okay? Use this version, right? Part 3. Use the equation you wrote in C part 2 to find the threshold wavelength of the photo emission. Right? How are we doing that? We have everything we need already, right? We have the energy of the photon and we found that somewhere. We have the energy of the photon here. So that's 4.9725 by 10 to the minus 19. Right? Work function is what? HC on the actual threshold wavelength. So HC on lambda naught plus the kinetic energy. What that is? Tell me quick. Hello?
Like I think you just started them. Okay. I don't know. It's not a good thing. Yeah. Yeah, but I don't. But they're yeah, what's I think those
I'll get you there. I'll give you all time to work it out. Oh yeah, I was asking this here, Yash. What's the energy that's going here? Alright, I'll organize it.
This month, we'll say, the best of us still.
Krishna, to come tomorrow. I'm keeping out my one. I'll put it. Yeah. Very good. 1.3 by 10 to the minus 19. And if we arrange and you solve for lambda, right? Minus. How much you got? Question: should it be more or less than this? Threshold. Threshold is the maximum or the minimum? Max. So it should be more. How much? Just minus and
5.42.
Yes, sir, what you see?
for real?
Yeah.
You work for the whole thing?
Yeah.
You work for the whole thing? That's all.
See this?
So it's this minus this, and then you divide this by it.
So what's it's
So it's 4.9. That's not 4. So it's 6.63 by 10 to the minus 34. 3 by 10 to the 8 all over. How much is that?
I can't solve them.
Calculator. I just work it out one time, right? Minus this, and then this divided by that.
5.4 times. It equals right. Yeah.
5.42 by
10 to the minus stuff.
minus.
So.
Say minus 9. check back ChatGPT and see what it make a mistake. Mental maths. Right, so that's about 542 nanometers, which is more than that, right? So you're saying no, you do the right thing. Okay. By time already, we get to the graph. Right, last part. Wait, just listen to the last part. This will go to point pick one. Jacob, let's try and get some right today. State with a reason, Jacob. State with a reason whether or not NAF will win on Monday. With a reason.
What?
With a reason, yeah. State with a reason. Wait, no, not here. State with a reason whether or not photoelectron will be emitted if the radiation of the wavelength, if radiation of wavelength 618 nanometers is incident. Huh? 680 because it's more than, so nothing will happen. Okay? Alright, you think I do the graph, so we'll do the graph first thing next week and then move on, right? If you want to read the handout, read the Berkeley wavelength. That's the next page, right? So next week we'll continue with that. We have lessons of all of November, yeah? And then I'll give you a week in December and then any holidays. Right? So you want to finish off module 3. And module 1 is all next year.